Yeah, we are looking at the second and higher derivative, part two. And we have these questions. Uh, Find the second differential if y is this. That's one. Two, y equal to what? Cos x over 1 minus sine x. So let's see our solution to that and find the second differential. This question. The first one, y is equal to what? Cos square x. Okay? Don't forget, this one means cos x, and you can use product rule. Okay, but I'm not going to use product rule. I'm going to use functions of functions. Very soon, shortly, the next video, you see the video on functions of functions. So this one will just be equal to your y prime will be equal to the two here will come to the front. Okay, you differentiate the base here, the derivative okay, the two will come to the front. Okay, then you have cos 2 minus 1 to remain 1 power, so cos x, then times what? The derivative of this, which is what? Minus sine x. Okay, and that will give you minus 2 sine x cos x. And if you're using product rule, it's very simple. If you're using product rule to be equal to y prime be equal to, you have two items here, take one constant, then differentiate the other one. Differentiate the other one. Okay, that's the differential coefficient of that. Then plus the one you are differentiating here. Can you keep it constant and differentiate this one? That also be what? Cos x prime. So that will be equal to, this will give you minus sine x. So that will be minus sine x cos x. And this one also will give you minus sine x cos x, because the ratio of this one is minus sine x. So that will give you minus 2 sine x cos x. So that's that. Minus 2 sine x cos x. Okay. Um, then that's the first differential. Can we do the second differential? The first differential is minus 2 sine x cos x. The second differential will be equal to y prime prime, okay, which is same thing as the square y dx square. Okay. The minus 2 is a constant, so I'm going to take the 2 minus 2 outside. Okay, I'll take sin x constant, this is a product rule, take sin x constant, then differentiate your this one, that's cos x prime, then plus the one here, which you are doing, can you keep it constant here, that's cos x, then differentiate your sign, the one you are keeping constant here, sin x prime, then close your bracket. You don't want to use prime on top of it, just ddx of that ddx of that. Okay, so that will be equal to minus 2 into bracket. The derivative of this one is minus sine x, so that will be minus sine square x. Okay, then here also this is cos x, so that will be equal to what? Plus cos square x. Okay, then you can rearrange this is minus 2 into brackets cos square x, write the positive first, minus sine square x, and that's equal to what? This is cos 2x, so minus 2 cos 2x. So that's that on that the second differential of that question. Y equal to cos x over 1 minus sine x. Okay, so this is this. My u in this case is cos x. My du dx is minus sine x. Okay, minus sine x. My v is 1 minus sine x. That's the denominator. Then the b dx is equal to minus is already here. The derivative of constant is 0. So minus is there. So minus cos x. The derivative of cos is sine is cos. So let's do the substitutions into the quotient rule, which is a v du dx minus u dv dx over v squared. So let's substitute that. So the first differential, y dx is equal to v 1 minus sine x times du dx minus sin x, then minus u cos x times dv dx 1 minus sin x all over b square 1 minus sin x all square. So let's do the expansion. So minus sin x times 1, that's equal to minus sin x. Minus times minus, that's plus. Sin times sin, that's sin x squared. Here also, minus cos x times 1, minus cos x. Minus times minus, that's plus, that's sin x cos x all over 1 minus sin x squared. Okay? Good. Let's check the substitutions. Let's check the substitutions we have. Because making it to a long, there's no mistake there. Cos x minus 1 sin x. Okay? This is my b, 1 minus sin x. Times derivative of the numerator. Okay, that's minus sin x. Okay? Then minus the u, then the dx. The dx is minus cos x. U, the dx. So that's a mistake here. So that's what I'm looking at. That's something there. There's a mistake here. Let's correct that. Yeah, u cos x, then times the v dx. The v dx. That's minus what? Minus cos x. So that will be equal to this one times this one, this one times this one. Okay, then followed by this one times this one, that's plus cos square x. Yeah, so that's what we have there. So and that will be equal to sin square x plus cos square x, that's 1. So that's equal to 1. Let's write the 1 first, then minus negative minus sin x all over what? 1 minus sin x square. So 1, it will cancel out. So we now have the first differential. We have the first differential as sin x and 1 minus sin x and 1 minus sin x, they cancel out. We have 1 on top and we have 1 minus sin x at the bottom. Okay, then the second differential will be equal to minus the b dx over b squared, because my u is 0, my numerator is 0. So that will be equal to and if you want to do this formula, just do your normal something. See quotient you are using. Okay. So the differential coefficient of your v is minus into brackets. If you differentiate this one, you're going to have, don't forget you have minus here. So that's minus cos x. Okay. The minus that is here is here. The derivative of 1 is 0. And the derivative of this one is cos x. All over 1 minus what? 1 minus sin x all squared. And that will be equal to cos x. 1 minus what? Sin x all squared. So that's that on that question. Okay? Just that you have to be observant of what you are doing. Okay, don't make mistakes. Okay, this is your u, and this is your dv dx, which is minus cos x. So that's that on that. Let's take more questions. More questions here. If y is equal to this, show that this is equal to this. Okay, so let's quickly do that without wasting time. So I think this should be question 3 now. Then that should be question 3. Okay, so in this case now, this is very simple. Can we get the dy dx? The dy dx, if you differentiate tan x, you have what? Sec squared theta. Okay, so that's what we have there. Okay, can we do the second differential? This one means sec theta times sec theta. So let's do the second differential. D dx of the first differential, which is what? The square y, the square theta, the square y. What am I writing? Even the first differential is the y, the theta. It's the y, the theta. So the second differential will go to what? The y, the square y, the theta square. Okay. So that's how it should be. Then you keep one constant. You keep the first one constant. Then you use a product rule. You differentiate the second one. Sec theta. If you differentiate sec theta, that will give you sec theta tan theta. If you differentiate sec theta. Then plus. Okay, plus. The one here, keep it constant and differentiate again sec theta. Okay. Also, I kept this one constant. Okay, and I went for this. Okay. Now, I'm not keeping this one constant now. I'm not differentiating the first one, which is what? Sec theta tan theta. Okay. And that will be equal to sec squared theta tan theta plus sec squared theta tan theta, which is equal to 2 of that, 2 sec squared theta tan theta. So what we do is that already we have tan theta as y. So can we also, we don't have to, we have to remove tan theta because there's no tan theta here. Everything must be in form of theta. So, and don't forget the identity that one of the identity that says that 1 plus tan squared theta is equal to sec squared theta. Okay. So I want to plug in that in this equation. We plug in that. So we now have the square y, the theta square is equal to 2 into bracket 1 plus tan square theta. I'm making substitution for sec square theta, which is equal to what? 1 plus tan square theta and then tan theta. Okay. Then finally, what I need to do now is to write this one, 2 times this one, that will be 2 tan theta into bracket 1 plus tan square theta. Then the next thing to do is to make substitutions. So my tan theta is y, so that will be 2y into brackets 1 plus tan square theta, which is what? Y squared. And that proved the work. That proved the work. Okay. On the screen, we have if y is this, where n is a positive integer, show that number 1 and show that number 2. Okay. Let's quickly see the solution to that. We have y equal to theta. Y is a function of theta. Okay. So the first differential will be equal to what? The first differential, the y d theta, will be equal to this n will come to the front, and then you have this, and then subtract 1 from that. Just like the normal differentiation, general formula, y equal to 1 x n. The n will come to the front, and then minus 1. Okay, so that's what we've done there. So then the next thing to do now, because if you look at the when you are showing, you have to have in view the final result, the targets. Okay, then you can see that this is being multiplied by what? By theta. So multiply this equation by theta. Multiply this equation by theta. Multiply this equation by what? By theta. So we have theta dy, okay, equal to what? N dot theta. So by the time this one has power 1, so and theta as a base, so you are adding together, so that will be equal to n theta n minus 1 plus 1, because they have the same base. So you take one of the bases and add the power together. So this minus 1 plus 1 will cancel. Then you have n theta. You have this. Okay, and that's what we are told to do, and that will be equal to n. This one is y. So that is done. That is done. Okay, so let's get the done. Let's get the second one. Then second differential. Do the second differential. Second differential of the first one. Question start. Now we go to n. This one, this power will come to the front. N minus 1. Then theta. Then this exponent minus 1. N minus 1 minus 1. So we have n into bracket n minus 1 theta n minus 2 minus 1 minus 1. So that gives us n minus 2. Okay, this square y the theta square. You can call this one equation star 2. Can you multiply that equation star 2 by theta square? Multiply by what? The equation star multiply by theta square. Equation 2 star. So multiply by theta square. So we have theta square, the square y, the theta square is equal to n into bracket n minus 1, theta n minus 2, and then times theta square. So without wasting time, do the same thing I did here in this place. So the same base, apply indices, then you have what? N into bracket n minus 1 into bracket. This will just become this because minus 2 plus 2 will cancel. And that will give you n into bracket n minus 1. And this one is what? Is y. So that is done. Okay? So that's that on the second and higher derivative. So please, if you are still not subscribed, please do that now so that as we upload, you get notified. Thank you for that.